Okay, I think it's working now. Hi, my name's Michael Richardson. I came to you during RIPE 77 to talk about the Secure Home Gateway project at Sierra Labs. And I'm here to talk to you about a little bit of update of the project, but mostly about some of the issues that we've come into with respect to what are we going to do with misbehaving devices. So I'm here to talk about an unquarantine playbook. So the history of the project is the Mirai attack happened in 2016. A lot of infrastructure people got pretty concerned that IoT was going to weaponize the world and decided that we needed some way to prevent the mass number of light bulbs and other devices of questionable quality from killing the internet. So the idea was that we will have to put firewalls in every home, and they will protect the internet from the devices, and it will protect the devices from the internet. So we started building a project and a project team, and as we did this, we ran into a lot of other people who are doing similar things, and this is a kind of a list of the various people and projects and standards bodies and things like this that are happening. And we are in kind of our phase 3 now. So phase 1 was a proof of concept that you saw in October. Phase 2 was a bit hard to describe, but was basically us turning our carefully hand-built set of experiments into a product process based upon something we could reproduce. And we're now in phase 3, where we are trying to norm ourselves into a repeatable iteration and agile process. So you should see something very tangible from us very soon. So what is this about? So we get a device and it's maybe not so good, and we want to take it offline, and what should we do? And so we written a couple documents about what will happen when the devices are offline. And the document I want to talk about today turns out to be called a playbook. And it's about what should we do when a device is offline? How do we get it back offline or taken out? So what happens? You have a refrigerator, and it may do something interesting or not. And maybe you have some other devices, some medical device on your home network that you care about really being alive. So the refrigerator attacks something, and it's regrettable, but let's say it happens. And the refrigerator is quarantined. So basically that means that our stuff works, and the firewall says, well, you weren't supposed to do that. I'm taking you offline, and I'm going to send an alert to the end user, the homeowner that says there's something wrong with your refrigerator. So who do you going to call? You could call the application developer and give them a 1-star, because clearly their application sucked. It didn't fix your refrigerator. You could call your home router vendor, because that's what sends you this alert. You could call your ISP help desk, and it's probably what you would have done when they disconnected you because your refrigerator was bad. But now you've prevented yourself from getting disconnected, but you might still talk to your ISP. They might talk someone else. Maybe they're going to call a national CERT or something else. Maybe they're going to do it through some set of protocols rather than with the phone. And maybe that's a good thing. What else could happen? Well, you could call the refrigerator manufacturer. That would obviously be a really good thing to do. And so it's in green. That's where we really want to get to. So the question is, how do we get from there, from all these other possibilities to this possibility as quickly as we can? And you might actually wind up talking to your hospital or medical provider to make sure that that device that was supposed to really be online, that is really still online. Is everything else okay? So what about the device itself? So it's offline. We figured out maybe who to call. And we hope that these various people are going to get some information about the device. So at the beginning, your device has nothing. It just came out of the box. You probably haven't configured it. You haven't invested any time or energy in it. You haven't given it a name. It hasn't become part of your family. And if at that point we told you need to upgrade the firmware and wipe all your settings, you wouldn't really care. That'd be okay. No problem. But now that it's in use, it knows which kind of food you like, it knows the relationships and has some logins to your favorite grocery stores, you're a little more reluctant to kind of take it offline. It does useful things for you. So if you're going to do something, you kind of have to know it's going to be real. So it does something weird. You call it suspicious. It's the first state that we think that it belongs. And something should happen, and we were trying to figure out what does this mean, but we think that we need to inform people. Perhaps it's not suspicious. Perhaps the rules are just wrong, and the device goes back into a normal state. So next, what happens? Well, maybe it is suspicious. It's a device of interest, to take a term from popular TV police shows. And at this point, maybe the telemetry from the device, what did it do, is being handed over to someone who actually knows what they're talking about, and is trying to decide, is this something really we should be concerned about, or is this something maybe it's just happens? Okay. The device maybe is at this point owned. We can't be sure one way or the other, but let's assume it's a possibility. So now we have a suspect. The device has a vulnerability. Maybe it's done something quite terrible and it needs to be offline. You could have that information from external sources. For instance, if someone else decided that all the refrigerators of a particular brand and model had a vulnerability, then you would go straight to suspect mode. And the important part of suspect mode is that the next step is it gets quarantined. So the device is quarantined. It's still operational. That is, your refrigerator still keeps your food cold. It doesn't order new groceries. It doesn't keep track of your to-do list, and it doesn't do anything else that you might be the smart operations that you want it to do. You might have a device that has no usable activity. An Echo or a Google Home or a Mycroft, without internet connectivity, what does it do? Nothing at all. So you probably have to disable it, and you remove the power, you remove the batteries. Maybe it's unfixable at this point. We don't really know. But you know that at this point you can't really do anything. It has no usable non-smart abilities, and so you should disconnect it. At this point, if the device is unfixable, what happens? Well, does it need to be destroyed? One of the worst cases possible is the device gets sold to some unsuspecting user who has no relationship with the original manufacturer, and it goes back into service in a place where it's going to attack the internet again, and it hasn't even been upgraded. So that would be terrible. And I would hate to have all these devices wind up in the landfill, but if they're not fixable, and there's no open source, and there's no patches for them, then what can they do? Recycle them? Send them back to the manufacturer? I don't know. I'm not happy about that, and you shouldn't be either. But let's talk about realistically, that's where some devices are going to go. If life is good, however, from quarantine, we get an upgrade. We have a new firmware, and the device loads the new firmware. This is happy. The device restores whatever backups it has if it needed to do that. If the firmware upgrade wiped out settings, then it gets them back. And it somehow says, okay, I'm ready to go back to normal. I'm going to reboot once or something, and maybe you need to give me some network settings again, and then I'm going to go back to normal operation. That's awesome. And what would be really awesome is if the device could go through all these states without pissing off the user or the ISP. So if we add some protocols to this set of lists, let's see how could we automate parts of this. Well, one way from the nominal to suspicious is potentially with a DOTS client running on the home router that lets the ISP know something's going on. Right now, this is generally done with a PDF file of information from place to place, passed around from ISP to ISP. The suspicious to normal may be signaled by the presence of an update to a MUD file. There could be a lot of other interesting places, and this is where I would like to have some discussion. What else things would say, well, this device, it did something weird, but let's just keep going. It's okay. The new MUD file would presumably have a new set of descriptions that allows the device to do these things that it was suspicious doing and now is there. But if it turns out it's a problem, the ISP would like to tell someone. So MILE is a possibility, and there's a protocol called ROLI that's being discussed. It's a RESTful version of some other things, and ISPs are in some cases going to be using this to communicate with other ISPs about what's going on. So, device of interest goes around. Some ISPs communicate about it. Yes, I have one. Yes, I have one. Yes, I think we've been observing the same problems you've been observing. And right now, this is handed around with a PDF file, and the MILE protocol should be able to handle this kind of thing. So now it's suspect. It gets, we're pretty sure it goes into a database of what's going on, and now we have to tell the home routers and tell the other ISPs what's going on. And there's a bunch of possibilities here involving MILE, the European-led MISP project, DHS-led project called Taxi, which looks like it's going to incorporate ROLI, and there's another NIST product called SCAPT v2, which involves ROLI. I'm very curious if any of the ISPs in the room are involved in any of these projects. If you have some comments about this, it's not my area of expertise, but what I really want to do is interact with and find people that are dealing with this stuff, and how can we in the secure home gateway space best interact with ISPs that want to do this kind of stuff. So the device got quarantined, and something's got to go be upgraded. So the IETF has a SUIT working group, which is software updates for Internet of Things, and how we find out about the update is out of the scope of SUIT, but the existence of the update is enough to say, hey, let's start doing something. Let's get the device online enough such that it can get the update. And the SUIT protocol would allow us to find out that the update is newer, and that potentially it deals with issues that we have found. After